List comprehensions with sugar.collect in comparison against Python's list comprehensions. In this video, we will go over sugar.collect, its pros and cons, and compare it against Python's list comprehensions with some benchmarks. The code for this video and its script documentation, styled with nimib, is in a link in the description as a form of written tutorial. List comprehensions. Sugar.collect is a macro used for list comprehensions. A list comprehension is basically making a list from an existing list based on some variable parameters. This can be done with either a for loop or sugar.collect, list comprehensions in Python. nim, comprehending a list with a for loop. In the following example, we make a new list sequence based on the fruit sequence by iterating over it with a for loop using the pairs iterator and returning only the elements of the list starting with the letter P. Python's list comprehension structure. Before we go on for the Python's version of the above example, here is the structure of a Python's list comprehension with explanation. Slightly different than in nim's for loop. First, you start with what you want returned, and then, just like how in nim, for element in container, and then the condition. And once this list comprehension finishes, it will make a new list with the returned elements based on the conditions. Python, comprehending a list with a for loop. So a list, which would be a sequence in nim, and then an empty one. And then for all the fruit in the fruit list, if P in F, and then append, which would be .add in nim, and then print, which is echo in nim. Nim, using sugar.collect. The exact same code as the one with the for loop, except now it uses the sugar module's collect macro. Instead of creating a new sequence beforehand, before this for loop, and filling it with all the fruit that start with P, we make it right here, and then assign to it collect, and then the rest works just the same. This collect is slightly different than a normal one. A normal one would simply be collect with this. This one uses the new sequence proc, which creates a new sequence and fills it with 0. This is for making more efficient sequences that you then fill by index instead of add. Pre-allocation is what it's called. Python, list comprehension. So the list, which is a sequence in nim, and then F will be returned, and then just like in nim, for F in fruit, 2, if P in F. So every F is this, and it will return all of the ones that start with P. And then print, which is echo, and result. Python's list comprehensions versus nim's collect. Python's list comprehensions are a more compact way to create new lists in situations where map and filter and/or nested loops would be used. They are great for simple tasks. Here are a few examples with a list comprehension and a for loop for each. Python's list comprehension cons. Python's list comprehensions are useful for small and simple lists, but become extremely hard to understand the more complex they become, unlike just using a for loop, which is yes, more verbose, but also easier to understand and read, especially if you haven't viewed the code with a list comprehension for a while. Here is a good example of a bad one-liner. The above good example of a bad one-liner can be greatly improved by indentation, like a for loop, like this. Yes, it's more verbose, but understanding the logic behind it should be much easier. This is not that complex of an example. This first container is just for show. So you go in it and you get to this one, and then you do it again, and then you get these three. And then if the element is not by the modulus remainder of 0, so not even, it will return these elements. And 2, 4, 6, 8 will be returned. NIM's sugar, collect, prose. Long one-liners are bad. NIM does not do list comprehensions as one-liners like Python does. They work very much the same as a for loop, but reduce a bit of typing by not having to declare initialize a sequence beforehand, but at the moment of usage. Then we also don't need to call .add plus element we want, but just the element we want. Sugar collect also works on sets and tables. NIM's sugar collect also works on hashSets and tables, unlike Python. NIM's collect macro does not have the drawbacks of Python's list comprehensions, while being much more powerful, because collect also works on other types, these types being sets, hashsets, and tables. Collect with sets. Simply a normal set, then we declare a variable, collect on it, and then for every element, number in normal set, and then use the modulus and return. Collect with hashsets. So import them, and then a set of tuples with string as the first field and integer as the second. So first, the normal version without sugar collect. So we declare a variable oddkeys as a hash set of string and integer for these tuples. So, and then in the for loop for the tuple in key value set, and then if tup1 field 2, so 1 by modulus 2 not equal to 0, which means it will not be even but odd, and then odd keys that include that tuple, and we get this result. And here is the collect version. So instead of declaring a variable beforehand, we declare it here and then call collect on it. And then instead of including that tuple, we simply write the tuple and we get the same. Well, a sequence instead of a set, but it doesn't really matter for this example. Collect with tables. So import tables, and then the table has string for its key, and then sequences of type string for its value. And it's an order table. Use them over the normal ones. So first we make a new variable, a empty table called staff wielders, because we're gonna be finding staff wielders. Don't forget parentheses. And then for every class, items in character class equipment, for item in items, if the item is a staff, we put in a new entry. This is how you make a new entry in a table. And these will be wizard and druid. So, and here is a collect version. So instead of having to declare an empty table beforehand, we do it here with collect. So this is much shorter. And then instead of putting new entries in like this, we do it like this. And the result. Performance benchmarks. Now I will show you performance benchmarks of free variants of making a new list in both Python and NIM. This is not a benchmark of the languages. This is only meant to see the difference of the free variants. These are my relevant computer specs. If you intend to recreate the results, you have to know that unless you use the same specs, the results will be different. The free variants are as follow: add for NIM, append for Python, index square brackets for both, and collect for NIM, and list comprehension for Python. All free variants of the two versions of NIM and Python create a new list by filling a pre-initialized to size 10,000 sequence array with arbitrary data that is then benchmarked 10,000 times in order to account for slight variations that occur. The resulting time elapsed is then divided back by 10,000 to get the mostly correct approximate time elapsed for our variations. This is eased for NIM by the usage of a custom template, while Python has an official module specifically for this purpose. NIM's free variants. So this template will ease this benchmarking. What it does is, first it captures CPU time at the beginning, and then it runs the code a number of times we want, and then it subtracts the first timing from the current one to get the timing. And then we do some string formatting so that we get the precision all the way to 12 decimals. If you set it lower, obviously you're going to get less, but we want this to be as precise as approximately possible. And here is the first benchmark for NIM. Simply call the benchmark template, and then the first argument that is string for naming the benchmark. These empty spaces are for formatting reasons, so that we get the same aligned results, and then the amount of times to run. All of these examples will run 10,000 times, like I said before, and all of them will fill or add to a list 10,000 times. So 100 million adds or fillings. So adding to a list, filling a list by the index, and using sugar.collect. And here are the results. For NIM, add and collect is basically the same, even though collect is a macro. Well, index is the fastest, which is going to be true for every single programming language out there. Because adding to a sequence or a list means that you have a size allocated for that sequence, and then every time you add, you basically have to make another sequence of a larger size to fit that new addition, and that keeps repeating, and this is very slow. It's much faster to just make a empty filled sequence beforehand and then insert by the index later on. Python's free variants. So the first example being the appending, add for NIM, and then by the index, same for both, and then the list comprehension. The results are quite a bit slower for Python than for NIM, but Python is a dynamically typed programming language, and implementations vary by every programming language, so this doesn't matter. Why doesn't NIM have proper list comprehensions? NIM doesn't have list comprehensions as part of the language, because what can be done as a macro should be done as a macro. This is a part of NIM's philosophy of keeping the language as small as possible, while implementing what is not required or needed as a macro in a usually separate module. Okay, that's it for this video. Thanks for watching. Like, share, and subscribe, as well as click the bell icon if you liked it and want more. You can also support me on Patreon if you so wish. If you had any problems with any part of the video, let me know in the comment section. The code for this video, script, and documentation are in the link in the description as a form of written tutorial.